Hi everybody, happy Monday. Hope you had a good weekend. Today we're going to jump into relative motion. Okay, so we ended last week doing some of those river questions, and that was relative motion as well. And today we're just going to break it down even further. And I'm sorry about this watermark over here. I'm just not attached to a smartboard. Okay, so relative motion, let's take down these notes. Okay, so our first thing when we see a relative motion question is to determine the object's velocity relative to the ground if not already done. So usually there will be two objects in the question. You need to make sure you know the velocity of each of those relative to the ground. Okay, so usually that will be like VA or VB. So then number 2 is to determine the relative velocity. Write the velocities as they appear in the question. So subtract the second velocity from the first. So you're going to determine the relative velocity, usually will be like VAB, so the velocity relative to A to B, and you write the velocities as they appear in the question. Okay, so subtract the second velocity from the first. And then the third thing is when entering the velocities in the equation, so VA or VB, make sure that the proper sign is used, right? Because those positive or negatives is our direction, right? Because these are vector quantities, not scalar. So the positive and negative are going to take over. So we're not going to put north, south, east, or west for these questions. We're going to put positive or negative. Okay, so make sure you have these notes down. So our first example here, if you want to draw this, draw these two little cars, again, always know that you're not marked on artistic ability, just give it a go. So this is our question. So we have car A, and it's a velocity of 20 kilometers per hour, and VB, we have a velocity of 10 kilometers per hour. So here's our questions. So number 1, what is the velocity of A using B as a reference point? So we need to know VAB, right? So our first rule there on the other side was to make sure we know relative to the ground, and we know that, right? So we know VA and we know VB. So we are going to try to find VAB, so relative from A to B. And then number 2, we're going to do the opposite, so B relative to A, so VBA, okay? So, number 1, VAB equals VA subtract VB. So if you go back up to here, right, so we have velocity A is going in the positive direction and velocity B is in the negative direction, right? So when we put this in our formula, so VAB equals VA subtract VB, that equals positive 20 kilometers subtract negative 10 kilometers per hour. And we get our velocity relative A to B is positive 30 kilometers per hour. Okay, so let's give number 2 a go, right? So we want to know velocity relative, or B relative to A. So we put VB, subtract VA. So negative 10 kilometers per hour, subtract positive 20 kilometers per hour. And we get negative 30 kilometers per hour is velocity of B relative to A. Okay? All right, number 2, some boat questions. So we have 2 boats here. We have boat A and boat B. Boat A has Bob standing on it up here. Okay, so there's 10 kilometers per hour and 5 kilometers per hour on boat A. And then boat B just has a positive 30 kilometers per hour. So to get velocity of Bob, right, so our question is determine the velocity of Bob relative to boat B, but we need to know velocity of Bob. So there are 2 velocities here. So we have negative 5 kilometers per hour plus positive 10 kilometers per hour, right? Because that's in that direction. We're going negative direction. So the velocity of Bob is negative 15 kilometers per hour. Okay, so determine the velocity of Bob relative to boat B. So Bob to boat B. So velocity of Bob relative to B is velocity Bob subtract velocity B. Right, so we have negative 15 subtract negative 30 kilometers per hour. We get positive 15. All right, so example 3 is sort of the same situation. So we have Bob on boat A, and Sally on boat B. Okay, so let's see our question. We want to determine the velocity of Bob relative to Sally. Okay, so first we know we need to calculate velocity of Bob because he has a positive 3 meters per second and a negative 25 meters per second. So add those together, right? Get negative 22 meters per second. Then we have velocity of Sally. So add these two velocities, so 4 and positive 30, so positive 34 meters per second. Okay, so to determine the velocity of Bob relative to Sally, we're going to do VBS equals VB subtract VS. Right, so plug those in, make sure you have the correct signs. So negative 22 meters per second subtract positive 32 meters per second. So VBS equals negative 56 meters per second. All right, example 4. 2 cars are traveling towards each other on a straight road. Car A is traveling at positive 35 kilometers per hour, and car B is traveling at negative 42 or 47 kilometers per hour. If the cars meet after 2.3 hours, how far apart were they originally? Sorry. All right, so first thing, let's draw our diagram. So we have car A going positive 35 kilometers per hour, and we have car B going negative 47 kilometers per hour. Then we do what I like to do is write out what's given, right? So we have VA is positive 35 kilometers per hour, VB negative 47 kilometers per hour. We know the time is 2.3 hours, and we're looking for our displacement. Okay, so we need to calculate VAB, right? Because that's what we need to use to find our displacement. So calculate velocity of A relative to B. So again, just subtract VA from VB. Do that work, get positive 82 kilometers per hour. Okay, and now plug that into our D equals VT formula. So our velocity of AB is 82 kilometers per hour, and times that by 2.3 hours. Okay, and you should get displacement of positive 188.6 kilometers. All right, example 5. A scooter is traveling at 75 kilometers per hour west. Okay, so this one we are using our directions, like our letter directions, okay? So if a car is 25 kilometers behind the scooter, how long will it take the car to catch up if it travels at an average velocity of 95 kilometers per hour west? All right, let's do our diagram here. So here's our scooter, right? It's traveling at 75 kilometers per hour. And if a car is 25 kilometers behind, right? So here's our distance. So negative 25 kilometers back, right? Here's car B, or car A, sorry, and that's traveling at a velocity of 95 kilometers per hour, right? So we have our car and we have our scooter. You can label it however you want, right? You can label this C and this S, right, for car and scooter. I usually do A and B. Okay, so we're trying to find out how long it will take for the car to catch up to the scooter. So that's our T, and we know our displacement, right, is 25. So again, we're going to use this rearranged formula of T equals D over VAB, and our unknown, we need to first calculate velocity AB. Right, so give that a go. You should now know how to do that. All right. So VAB equals VA subtract VB. So negative 95 kilometers per hour subtract negative 75 kilometers per hour. And these are negative, right, because they're going in the west direction. So our VAB is negative 20 kilometers per hour. Now we take this and plug it into our T equals D over VA formula. And our time is 1.25 hours. Okay? All right, now I think this is our last example. So, example 6. A car traveling at positive 90 kilometers per hour is passed by a 4.5 meter truck traveling in the same direction in 1.9 seconds. What is the velocity of the truck relative to the car and relative to the ground? Okay, so our first thing, let's draw our diagram right at what's given. Okay, so what's given is VB is 90 kilometers per hour. We don't know the velocity of A, so when I drew this, I did my truck as A and car as B. Okay, so like I said, if you want to do truck as T and car as C, that might make more sense to you too. Right, so we have our displacement of dA relative to B is 4.5. We have our time, 1.9 seconds. We're trying to find VA relative to B, right? So VAB equals DAB over T. And we have all that information. So 4.5 meters divided by 1.9 seconds. We get our VAB to be positive 2.3684 meters per second. And then we can change that into kilometers per hour here, okay? So that's what this is 8.5263 kilometers per hour. Now, we need to calculate VA, right? That's our other unknown, is we're trying to find relative to the ground. So that just means when it's VA or VB. So we set up our normal equation, VAB equals VA subtract VB, but this is our unknown. So you can rearrange and add VB over here, or you can just fill it in like this. Okay, so use kilometers per hour because that's what we have our velocity in over here. Okay, so plug it in, hopefully you get this answer. And positive 99 kilometers per hour equals velocity of A, so the truck to the ground. Okay, so hopefully this makes a little sense. You are going to get a worksheet now to work on. What you don't finish today, we'll work on tomorrow. Okay, good luck.